We're going to now look at continuity to point, but with algebra, most of this is going to be dealing with piecewise functions. I think if not all of it's dealing with piecewise functions. So let's take a look at this first example. So they want us to answer if we're continuous at this particular spot of x equals 2. So if you look at this function, it splits off at x equals 2. So we kind of have a possible issue of a jump discontinuity. Another thing you need to check though is make sure that one of the 2 points, not both points, it can't be both points, but one of the 2 points has to be closed. Because check it out, what if they both stayed open, and let's just say the left and the right limit are the same, it would not be continuous because that point is still open. So we do need to make sure, and it does check off, this one is closed, so that's good. So let's go ahead and take a look at the algebra now and see if the limit from the left and the right is the same. And I notice the left is closed, so let's see if these connect basically. So I'm going to go ahead and plug in the 2. So I'll get from my left hand limit, so the limit as x approaches 2 from the left is natural log of 2. And you can plug that in a calculator if you want. But you'll see the limit as x approaches 2 from the right, which would be this one, would be 2 squared natural log of 2, which is 4 natural log of 2. 4 natural log of 2 and natural log of 2 should not get you the same thing. So what's going to happen is you're going to have this jump discontinuity there. So no, it is not continuous. Let's go ahead and let's take a look at, let's do some trig. So for this one, is it continuous at 0? So we see there's that split at 0, so let's check the left and the right. So I'm just going to put LHL for the left-hand limit. One over cosine of 0. Cosine of 0 is 1, so that's 1 over 1. So pre-calculus, don't worry, we'll go over how to find cosine of 0 later. For calc, you should know that from the unit circle. Then for our right-hand limit, we get cosine of 0 plus pi, which is cosine of pi, which is negative 1. So those are not the same. So once again, we got something that's not continuous. Let's look at this one. So is it continuous at 3? Well, we can see there's a split at 3 here. So left-hand limit is going to be 6 over. We'll plug in the negative 3. And I get 3. And then for our right-hand limit, plug in the negative 3. 9 minus 6 is 3. Now remember, we need to make sure it's included, otherwise it would just be an open point there. So it includes it on this one, so we're good to go. It's both the same from the left and the right, and the point exists. So therefore, this one is continuous. Once again, what if the left-hand limit and the right-hand limit are the same, but if that point doesn't exist, which it does because it's equal to there, so we're good. Then last one, is this continuous at 3? So 5, got a little lazy there, sorry. So for the left-hand limit, we get 5 minus 3, which is 2. And for the right-hand limit, we'll get 2 times e to the 3 minus 3, which is 2 times e to the 0. E to the 0 is 1. Anything to the 0 power is 1. So 2 and 2 are the same. So yes, and before I click yes, make sure that one of these, not both, you can't have both of them closed, but one of these has to be closed, and this one's closed, so we're good.